Alrighty then, I have some stuff to help y'all out with your lab 5 report, which is due tonight. I understand that a lot of you had some difficulties with it, so I have a lot to go through, and I'll be going kind of fast. You might need to pause at times to take a look at things. There'll be some parts that maybe don't apply to you, and you can skip over those if you got them, and other parts you will want to know how to do. Alright, so first part of your lab was you were given two functions and you had to implement them using first 8 to 1 multiplexer and then a decoder. So I'm not going to do your exact ones, but I will show you something similar. So if I had P of A, B, C, D equals the sum of the minterms 1, 2, 9, and 10, and R of A, B, C, D equals the sum of the minterms 0, 3, 5, 10, 11, 12. Then here's how I do these with a multiplexer. There's probably multiple ways to do it. So first I write out a truth table. So A, B, C, D. There are 4 variables, so there will be 16 different combinations. Alright, and now I'll label these with their minterms. So for P, that would equal 1 for minterms 1, 2, 9, and 10. And for R, it'd be minterms 0, 3, 5, 10, 11, 12. Now, for a multiplexer, I decided I would use 2 multiplexers. And my inputs, I decided to use for my inputs A, B, and C. Okay, so A, B, and C are my inputs. One, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then, so every 2 rows corresponds to a different value of A, B, C. So if I look at A, B, and C together, then this would be row 0, 1, 2, 3, 4, 5, 6, 7. Oh, I do this every time. There's 0 to 7, not 0 to 8. Okay, so if you look at the values of ABC's, first 2 rows ABC is 0 on both of those, and then 0, 0, 1, 0, 0, 1. And then I'll have this first one be P, and the second one be R. So I want to look and see what is the value of P, and now my only inputs left are D, so I can look at D and see what P is. P compared to D. So when ABC is 0, P is exactly equal to D. So if I filled in zeros where I didn't put ones, It might be easier for you to see. Okay, so see how P exactly matches D? So when ABC is 0, P equals D. So I put D in there. When ABC is equal to 1, notice P is the complement of D. When ABC is 2, P is always 0. When ABC is 3, P is also always 0. When ABC is 4, P is equal to D again. When ABC is 5, P is equal to not D. When ABC is 6, P is equal to 0. And also at 7. And then I can do the same thing for R. Whoops. R was 1 for 0. And 1 here, not 10, 11, 12. Okay, so alright, so when ABC is 0, R is not D. When ABC is 1, that should have been zeros for both of those. No, that's right. Yeah. Yeah, it equals D. Yeah, when ABC is 1, R equals D. When ABC is 2, it also equals D. When ABC is 3, it is 0. And 4 is also 0. And for 5, it is equal to 1. And 6 and 7 are 0. Alright. The next thing you were supposed to do was to implement it using a decoder. So for the decoder, I'm going to pause it for a second and redraw the table and not take up your time for that. Okay, so for the decoder, I decided to use the B, C, and D. I'm not sure why I did, but I did. So what this will do is it'll take the values of B, C, and D and look at them as a binary number, and it will output a 1 in the place equal to that number. So for example, if I have BCD is 0, 0, 0, BCD is 0, 0, 0, we would get a 1 in the 0 output. If BCD was 1, 0, 1, which corresponds to the number 5, I would get a 1 in the 5 and zeros everywhere else. And so if I look at P, I can see that if I just look at the values of B, C, and D, so that means if I draw a line right here, the values of B, C, and D repeat, and A changes. So the values of B, C, and D go from 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. So you can see that P equals 1 whenever B, C, D is 1 or 2, regardless of what A is. So it doesn't matter what A is. If B, C, D is 1 or 2, then P is equal to 1. So P will equal to the OR of the outputs of 1 or 2, 1 and 2. It's a little more complicated for R. You can see that for R, if BCD is 3, then that will give us a 1. Otherwise, when BCD is 1 or 2 and A is 0, so I will take the OR of 1 and 2 and AND it with the not of A. And then I can OR that to the 3. And then I can take the OR of 2 and 4, no, not 2 and 4, did I get 1 and 2 wrong? I did. One that was for P. It should be 0 and 5. So for A equals 0 and BCD equals 0 or 5, then I get that output. And then when A equals 1, and BCD equals 2 or 4. BCD equals 2 or 4. And A equals 1. And we have the OR of all of those. Okay, so that's the first part. I'm going to stop this here and upload it, and then I'll get to the code.